Hi, welcome to the video on evaluation metrics. By the end of this topic, you will be able to form a confusion matrix to explain the results of a classification model, describe different evaluation metrics for classification. So far we have studied about different models. Now, let's look at the other side of the coin. That is, we'll study about how to evaluate and choose the right model. For that, we will first learn how to interpret the model predictions systematically using the confusion matrix. For beginners, the confusion matrix, as the name suggests, could be confusing and difficult to understand, but we will make it as easy as possible to understand. Now, a confusion matrix is simply a n cross n matrix, where n represents the number of distinct classes in the target variable. But most of the problems only contain two classes, therefore, we will be working with a simple 2x2 matrix. One thing which you should note is that in binary classification, class 1 and class 0 are often referred to as a positive and a negative class respectively. We will be using this notation to explain the confusion matrix. Now, as this is a classification problem, we will have two possible outcomes with respect to both actual and predicted classes, and we label them as shown in the figure. Now for simplicity, let us first focus on the predicted classes. We know that a model can predict results as positive or negative, so we simply write P in the positive column and N in the negative column. Easy, right? But we also have the actual classes as positive and negative. So we will now start to compare the predicted classes to that of actual classes. Now, if the class predicted by the model is positive and the actual class is also positive, this means that the prediction made by the model is truly positive. Therefore, we can write T in the cell corresponding to the positive predicted outcome and the positive actual value. Similarly, if the predicted outcome is positive but the actual outcome is negative, which means that our predictions are false positive. Therefore, we can write F in the cell corresponding to the positive prediction outcome and the negative actual value. Again, if the predicted outcome of the model is negative and the actual value corresponding to that is also negative, this means that our prediction is truly negative. Therefore, we can write T in the cell corresponding to the prediction outcome negative and actual value negative. Now in the last case, if the prediction outcome is negative and the actual value is positive, it means that prediction is false negative. Therefore, we can mark F in the cell corresponding to the prediction outcome negative and the actual value as positive. Though the confusion matrix is a bit confusing for beginners and it might result in making errors, but if you follow the systematic way we just followed, there is no way you can make any errors or mistakes. So we learned how to make a confusion matrix, but how is it going to help us? The confusion matrix serves as the basic platform of representation for most of the classification metrics. There are a lot of metrics which can be derived from the confusion matrix, but we will only be covering the most essential ones, such as accuracy, precision, and recall. Let's discuss the first one, that is accuracy metrics, in the next video. See you then.